page 5 of the computer system notes, and continuing on the memory access section, we're going to talk about size prefixes. We're going to draw a table here. So SI is an international system of measurements and weights and stuff like that, and they have prefixes that they specify. So SI, in case you care, stands for Système International, so it's a French name. I took French all through high school, but went up to grade 13 in my day, and I'm terrible at it. I knew a French lady from the Congo, and she couldn't understand me in English or French, so she would just giggle when I talked. Anyway, so so we've got SI units. This is what prefixes that we're used to using. So K, M, G, make sure I do this in the right order, T, P, and E. We'll stop there. You'll notice that those are all uppercase except for the K, and there's a reason for that. So K stands for kilo, M for mega, and so on, and their magnitude is 10 to the 3, 10 to the 6, and so on. Kilo is lowercase because an uppercase K stands for Kelvin, so the uppercase K was already taken. That's why it's a lowercase, whereas the others are uppercase. G is giga, so you probably have memory that's sized in gigabytes. You probably have a hard drive in a personal computer that's sized in terabytes now, so that's 10 to the 12. Peta is 10 to the 15, and exa is 10 to the 18. So nowadays with large supercomputers, they talk about exascale computing, and what they tend to measure on these supercomputers is the number of floating point operations per second, so flops. So if you got an exaflop computer, you're doing 10 to the 18 floating point operations per second. And if this interests you, there is a website called top500.org where they benchmark supercomputers from around the world twice annually, and they list the results. And usually the US and China has a couple of the top supercomputers in these rankings. And the architectures they use they vary. So I think the top one right now is the Chinese Tianhe 2, which uses a custom processor that they designed for that supercomputer. Others will use AMD multi-core processors, so the trying to remember the word now, their latest Zen processors, I guess. And others will use a combination of multi-core processors and GPUs. There doesn't seem to be a magic formula. So anyway, that's I find that stuff kind of interesting. Okay, so then the other set of prefixes is IEC, and that stands for the save a little writing here and abbreviate this, the International Electrotechnical Commission, and so all their prefixes look like the SI prefixes, but with a lowercase I added afterwards. And I'm not sure if you've seen these prefixes used before. I mean, if you've been writing notes for this section of my notes, then you've seen that I've used kibibytes and mebibytes and I think tebibytes so far. So Ki, the way it's said, is kibi, and these are powers of 2, hence the bi for binary. So the magnitude of a kibi is 2 to the 10, which equals 1024. So it's close to 10 to the 3, but not exactly. And then mi is, whoops, not megi, it's mebi, and that is 2 to the 20, and hopefully you can see the pattern here now. Gibi is 2 to the 30, so roughly a billion. Tebi, 2 to the 40. Pebi is 2 to the 50, and XB is 2 to the 60. And you might be wondering why I use these things, and they're more accurate if you're talking about something that's sized by powers of 2, and most computer hardware is sized in terms of powers of 2. So registers are either 32 bits, which is 2 to the 5, or 64 bits, which is 2 to the 6, and so on. And computer memories are usually powers of 2. The one exception to that is hard drives. So hard drives are sized in powers of 10, and they are reported with SI units accurately, whereas memory has always been reported using the SI prefixes, when in fact they should have been, that's a little inaccurate. So memory, it's the size is in powers of 2, but they are, and I'm going to emphasize this with green ink, inaccurately reported with SI prefixes, or that was the long-standing custom. It's starting to change. So what I mean by that is 1 KB or kilobyte of RAM should actually be 1 kibibyte, which equals 1024 bytes, because that's just the way memory hardware works. It doesn't work in powers of 10. The addressing is always taking a binary, is taking the address as a binary number, and it works better. But hard disks, I'll just say HDD, they are sized with powers of 10, and put this in green again, accurately reported with SI prefixes. So if you get a 1 terabyte hard drive, you're getting 10 to the 12 bytes of storage. So let's write that out. 1 TB, 1 TB HDD has 10 to the 12 bytes, not 2 to the 40 bytes. And I haven't looked this up in a long time, but apparently at some point somebody sued one of the hard drive manufacturers, might have been Seagate, for not giving them as much storage as they thought they should be getting. They thought that it should be a power 2. So if my memory is correct, they lost that one. The plaintiff, not Seagate, because they were, supplying what they said they were giving you. Okay, that's it for this page.